Good morning, everybody. This is Ms. Hazel S. Matthias from the Department of Mathematics, KLS Vishwanath Rao Deshpande Institute of Technology, Haliyad. In the previous class, we were discussing about how to find the inverse Z transforms using method of partial fractions. About all these things we have discussed in the previous class. So let me briefly go through the method, how we have solved the questions or how we have found the inverse Z transforms using the method of partial fractions. U bar of Z will be given to us. U bar of Z will be given. Find next U bar both sides. Then whatever term we get on the right hand side, we will find the split that. Whatever function we get it over here, which is of the form U of Z by V of Z, we will split them in terms of the functions and we find the values of A and B, that is by the method of partial fractions. So we get an expression here in terms of Z, then we find U bar of Z, that we will multiply Z with the term whatever we get over here, then we find the inverse Z transforms. So finding U bar dividing by Z is an important step which you need to follow while using the method of partial fractions over there. So that was regarding the method of partial fractions. Here in today's class we will be discussing about finding the inverse Z transforms using the method of power series method. Here we need to know the general expansion of some series. Those who have learned Taylor series method, the present regular students, you all know how to find the regular using Taylor series expansion. We have learned that Taylor series expansion, Maclaurin's expansion, we have learned that. So this is quite similar to that, but there are only few standard Z transforms and the power series method. Using power series method, there are only few problems which we need to solve. The first one, what you need to remember, what is required here is the general expansion of log 1 plus x. So this is, you need to remember, log 1 plus x expansion is x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus etc. So this is the general expansion of log 1 plus x. So these are the things you need to remember here. Log 1 plus x is x minus x square by 2 plus x cube by 3 minus x power 4 by 4. This you can either obtain by binomial expansion or using Taylor series method. You can expand this. In second semester we have learned what is Taylor series expansion and Maclaurin's expansion. So now here one more thing is e power x. What is e power x? It is this, you need to e power x is plus x by 1 factorial plus x square by 2 factorial plus x cube divided by 3 factorial plus x power 4 by 4 factorial etc. So this is the expansion of e power x. What is e power x? 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. x power 4 by 4 factorial. Next, one more expansion what you need to remember is of 1 plus x power n. 1 plus x power n is 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial into x power 3 plus etc. So this is the third expansion. So these three expansions, these are the standard expansions which you need to remember. Because we are solving by power series method, we need these expansions help in order to solve those questions. Okay, so remember these questions, you can write down somewhere. I have given this in the notes as well, but you write down so that whenever I ask, it's easier for you all to tell. So let's begin today's class with the first question. I need to find the inverse Z transform of, find the inverse Z transform of log Z by Z plus 1. This is the first one. Second one is Z by Z plus 1. Okay, we need to find the inverse Z transform of these two functions. So first one we shall solve. I take that as u bar of Z. Let u bar of Z is equal to log Z divided by Z plus 1. So we shall take u bar of z as log z by z plus 1. Next what do I do is log z divided by, from this denominator is what? Z plus 1. From that if I take z outside, what remains? From the both the terms take z outside, what remains? 1 plus 1 by z remains. Am I correct? Z plus 1 is there. From this you take here, there is z term, so what remains? 1. But here there is no z term, so you have to multiply and divide by z. This z you take outside, what remains? 1 by z remains. Am I correct? Is it correct?
Yes, ma'am.
Okay. Now, here what happens? Z get cancels. So what we have over here is log 1 divided by 1 plus 1 by z. This is what remains. One more thing, what is log 1 by z? It is minus log z. Am I correct? Log 1 by z is minus log z. See, these are the properties of logarithms which you need to know. Log 1 by z is minus log z. So log 1 divided by 1 plus z can be written as minus log 1 plus 1 by z. Is it okay, everyone? Anybody wants me to repeat? Log z by z plus 1, z is kept as it is. From z plus 1 take z outside, 1 plus 1 by z remains. This z get cancels, log 1 by 1 plus z remains. Okay, 1 plus 1 by z remains. Then log 1 by z is minus log z. We have log 1 divided by 1 plus 1 by z, which is minus log of 1 plus 1 by z. I hope this is clear. Done?
Yes.
Yes, ma'am.
Okay. Now, so here we have got log 1 plus 1 by z. Just now I gave you the general expansion of log 1 plus x. What is log 1 plus x? X square by 2 x cube divided by 3 minus x power 4 by 4, etc. See, this is the general expansion of log 1 plus x. General expansion of log 1 plus x. This you need to remember, because now we need to expand what is log 1 plus 1 by z. Is it okay? So what is this? This is u bar of z. What is u bar of z? Minus log 1 plus 1 by z. So u bar of z is equal to minus log 1 plus 1 by z. That is equal to, apply this formula. It is in place of x what we have? 1 by z we have. Compare these two. Compare these two. Log 1 plus x is x minus x square by 2 plus x cube by 3 minus x power 4 by 4. In place of x we have 1 by z. Here there is a negative sign outside, so it is minus. In place of x we have 1 by z. So expansion is x minus x square by 2 plus x cube by 3, etc. X is 1 by z minus half times x square, that will be 1 by z whole square, plus 3 into x cube. X cube is x is 1 by z, so it will be 1 by z whole cube, minus 1 by 4 into 1 by z whole power 4 plus etc. This is an infinite series. Now, what do we get when we multiply this negative sign inside? It will be minus 1 by z. Minus of minus, it will be plus 1 by 2 into 1 by z square. Then this minus into plus will be minus 1 by 3 into 1 by z cube. Minus and minus will become plus, so 1 by 4 into 1 by z power 4 minus etc. So this is what we get it. Now, see, this is an infinite series. That's why we can write them in terms of summation. Summation from where to where, you have to tell me. N varies from where to where. Just look into the terms. I'll tell you all how to write the general expansion of this series. So this is a series you have got. You have to write it in terms of the general expansion, in terms of n. Look into the term over here. You have 1 by z, then here it is 1 by z square, 1 by z cube, 1 by z power 4. Correct. So you will have a term here 1 by z power n. Okay. When n equal to 1, you will get 1 by z. So you should start from 1 equal to 1, because when n equal to 1, 1 by z. When n equal to 2, 1 by z square. When n equal to 3, 1 by z cube. When n equal to 4, 1 by z4. So regarding, now what about terms you have over there? In the first case you have minus 1, second case you have plus half, third case you have minus 1 by 3, fourth case you have 1 by 4. So how can we write the general term over here? As you have alternatively positive and negative signs, here is a negative, positive, negative, positive. It should be a power of minus 1. Okay, it should be a power of minus 1, but that power is what you need to tell me now. When we have discussed about this while solving the questions in Fourier series as well. As you have alternatively positive and negative sign, it should be a power of minus 1. Minus 1 power what? It will suit this equation. Just check and tell me whether n suits, whether n minus 1 suits or n plus 1 suits. What does it tell me? Anybody?
N.
Yes, it minus 1 power n suits over here, because when n equal to 1, minus 1 power 1 is minus 1 and 1 by z. Correct. Now give and check different values for n. You put it in this expression and check whether you get back the same equation. When n equal to 1, it is minus 1 into 1 by z power 1. When n equal to 2, minus 1 power 2, it is plus 1. Divide by, one more term is missing. It is not only minus 1 power n. See over here. When n equal to 1, it is here it is 1. Here it is 2. Here it is 3. So it should be minus 1 power n divided by n. Then only we will get that equation. Now give different values for n. When n equal to power 1 by 1 into 1 by z, which is minus 1 by z. When n equal to 2, what happens? Minus 1 power 2 divided by 2 into z square. So which is nothing but 1 by 2 into 1 by z square, which is the second term. Now put n equal to 3. Minus 1 power 3 divided by 3 into 1 by z cube, which is minus 1 by 3 into 1 by z cube. This is the third term. Is it okay, everyone? Is it okay? That is, by analyzing you should be able to write the nth term. Writing the nth term is required over here, which is by that we will be able to z transform. So writing the nth term is also required. And we know the definition of z transform. What is a z transform? Definition: z transform of un is defined by summation n equal to 0 to infinity un z power minus n. Isn't it? This is z transform of un z power minus n. So compare this with your z transform definition. This can be written as summation n equal to 1 to infinity minus 1 power n divided by n into z power minus n. So you can compare this. This is the definition of z transform. You compare here, summation n equal to 1 to infinity, it should be from 0, but for 0 we are not getting any term over here, so you can take n equal to 0, it will be 0. This stands for un and this is z power minus n. So from this we got u minus we know z transform of u n. Transform of un is u bar of z, then inverse z transform of u bar of z is what? U. This you need to remember. You know from the definition. You need not remember that. That is from the definition. Am I correct? Definition of z transform. What is the definition of z transform? What is the definition of z transform? What is the definition of z transform? Forgot so soon. Z transform of un is given by summation n equal to 1 or 0 to infinity un z power minus n. So suppose if this series converges, then z transform of un is a function of z only. So z transform of un is u bar of z. So inverse z transform of u bar of z is what? un. So from this is u bar of z. U bar of z is what? Summation n equal to 1 to infinity some un into z power minus n. So inverse z transform of u bar of z is what? Un. So here un is what? Minus 1 power n divided by n. So this is our inverse z transform for the values of n greater than or equal to 1. And it will be 0 for n equal to 0, because for n equal to 0 we are not getting any term in this expansion. Is it okay, everyone?
Yes, ma'am.
Okay, I'll discuss one more question so that it will be more clear to you. Okay, the second part of that equation is, listen to me for the second question. Here u bar is given to be what? Z into log z by z plus 1. The second part of that question. So listen to this, so it will be easier for you all. First one also you will be able to understand. So more the question we solve, more we will be able to understand in a better way. So now again the same concept you have to use over here. It will be z into log z divided by, from z plus 1 we will take z outside. What remains? 1 plus 1 by z remains. Okay, from z plus 1 take z outside, 1 plus 1 by z remains, and z get cancels. So then you have u bar of z equal to z into what remains? Log of 1 divided by 1 plus 1 by z. This is what remains. That is equal to z into, see here, log 1 by z is what? Minus log z, minus log of 1 plus 1 by z. Remember this. Log 1 by z can also be written as minus log z. So log 1 divided by 1 plus z, 1 by z can be written as minus log of 1 plus 1 by z. Is it okay, everyone?
Yes,
Is it
ma'am.
okay? Okay.
Yes, ma'am.
Now we have the general expansion of log 1 plus x. What is log 1 plus x? Log 1 plus x is what? X minus x square by 2 plus x cube by 3 minus x power 4 by 4. So apply that to this term. We have u bar of z equal to z into minus log 1 plus 1 by z. Compare this. 1 plus 1 by z. In place of x we have 1 by z. So replace in this expression x by 1 by z. What happens then? 1 by z minus 1 by 2 into 1 by z square, because x is 1 by z, plus 1 by 3 into 1 by z cube, minus 1 by 4 into 1 by z power 4. X power 4 only. Power only it will be. Divide by 4, which is nothing but 1 by 4 z power 4. Okay, now what happens here? This is quite similar, infinite series it is, plus etc. You have to multiply by z. What happens when you multiply everywhere with the negative sign? Here you multiply everywhere, z get cancels, minus 1 remains. Then when you multiply here, minus of minus will be plus, half times z into 1 by z square, it will be 1 by z. Then when you multiply negative sign, it's minus 1 by 3 into z into 1 by z cube. 1 z get cancels, z square remains. Again minus z, when you multiply, minus of minus it will be plus, z into 1 by z power 4, it will be 1 by z cube, minus etc. It continues over here. So this is our u bar of z. Is it clear? Anybody wants me to repeat?
Repeat, please, ma'am.
From which step? This step?
U bar of Z, ma'am.
This step or this step? First one or second one?
Second one, ma'am.
Okay. I'll start from here. See, I hope this is clear till here. Is it okay till this step?
Yes, ma'am.
Okay. Then there is an expansion log 1 plus x, which is x minus x square by 2 plus x cube by 3 minus x cube of power 4 continues. This we can obtain from Taylor series expansion. Those who have done it regularly, they have learnt it in their second semester. These things. There are only few things, so you can remember this like a formula. Log 1 plus x is x minus x square by 2 plus x cube by 3 minus x power 4 by 4. Now here you need to apply that for log 1 plus z. Compare log 1 plus x with log 1 by z. In place of x we have 1 by z. So it will be in place of x. Here you have z as well as the negative sign. So z is over here, negative sign is over here. Apply the formula for log 1 plus 1 by z. Replace x by 1 by z. So what happens when you put x by 1 by z? 1 by z minus 1 by z square. So 1 by 2 into 1 by z square. Here 1 by 3 into 1 by z cube minus 1 by 4 into 1 by z power 4 plus etc. Then next step what? Here you can write this as minus z only. Z into minus 1 it will be minus z. This minus z you multiply to the entire expression. Minus z into 1 by z. Z get cancels, minus 1 remains. Then minus into minus it will become plus. Z here 1 get cancels. Only 1 by z remains. Then when you multiply z to this term, minus it will be minus 1 by 3. Here you multiply by z, 1 z get cancelled. So 1 by z square remains. Similarly, when you multiply minus z over here, minus of minus it will be plus. 1 z get cancels, 1 by z cube remains. So it continues. Is it okay?
Yes, ma'am.
Yes. Next, now we have u bar of z. We have to write this in terms of the summation. In terms of summation, just analyze and tell me. You see here, first term does not contain z. Second term contains z. But the powers do not match. So here you should be careful. It varies from n equal to 0 to infinity. What term and what power z you just, can you guess it?
1 by z raised to n minus 1, ma'am.
1 by z raised to n minus 1. We will check whether it happens. 1 by z raised to n minus 1. We put n equal to 0. What happens here? Z power minus 1. But in the first term there is only 1. There is no z term at all. So n minus 1 not possible. N possible. Okay, n is possible because put n equal to 0. 1 by z power 0. Anything power 0 is 1. So 1 by z, so you have here 1. Okay, 1 by z power n is positive. Check about the integer part now. This minus 1 is there. Here 1 by 2 is there. Here minus 1 by 3 is there. Here 1 by 4 is there. So how you can write it as? As you have here alternatively positive and negative sign, it should be minus 1 power something and divide by something. Minus 1 power something and divide by something. Check if you put what it will satisfy. Check whether if you put minus 1 power e by n it will satisfy. What happens? First step, it should start from 0. So it will be minus 1 power 0 divided by 0, which will be 0 only. But we have minus 1 over here. So minus 1 by n does not satisfy. What else might satisfy? Check with my n plus 1. N plus 1, whether it satisfies, just you check. N plus 1, put n equal to 0, it will be minus 1 power 1 and 1 plus 0, it will be 1. So minus 1 power 1, it is minus 1, so it will satisfy. Now go for 2. When n equal to 2, what happens? Minus 1 power 2 plus 1 divided by 2 plus 1, not 2. Here n equal to 0, now you should start with n equal to 1. 1 plus 1 divided by 1 plus 1. Minus 1 power 2 divided by 2, which is plus 1 by 2. You are getting 1 by 2 over here. Put n equal to 2 now. Minus 1 power 2 plus 1 divided by 2 plus 1. Minus 1 power 3 divided by 3, which is minus 1 by 3. That also is satisfying over here. So like this you need to do some trial and error so that you can write the nth term of that expansion. So I'll write it over here as it is minus 1 power n plus 1 divided by n plus 1. If you want, check once again by giving different values for 0. When n equal to 0, it will be minus 1 power 0 plus 1 divided by 0 plus 1 into 1 by z power 0. Minus 1 power 0 plus 1, which is minus 1 power 1 divided by 1, z power 0 is 1. So you have a minus 1, which is the first term. Now give n equal to 1. When n equal to 1, it will be minus 1 power 1 plus 1 divided by 1 plus 1 into z power 1, which is what? Minus 1 power 2. Minus 1 power 2, 1 plus 1 is 2 into 1 by z. Minus 1 power 2, it is plus 1 by 2, 1 by 2 into 1 by z, which is a second term. So this satisfies. Is it okay? Anybody wants me to ask anything? But little trial and error method you need to do. Just you have to check what satisfies by giving different values for n. So now this is of the form summation n equal to 0 to infinity un into z power minus n. 1 by z power n can be written as z power minus n. Un into z power minus n, which is what? U bar of z. Compare this with the definition of z transform. Z transform of un is u bar of z. So what will be inverse z transform of u bar of z? It will be un. So our z inverse of u bar of z is un. What is un? This term is our un. That is minus 1 power n plus 1 divided by n plus 1. Is it okay? This is little trickier. You need to use your analytic and little things properly. Some ideas, some concept you need to apply over here. Problem is right. So that you will be more acquainted with solving these kind of questions. Okay, so I have given however the notes. Listen to me carefully. So at the end if you have any doubt you can ask me. So we'll discuss next question. Obtain the inverse z transform of z transform of z divided by z plus 1 whole square by power series expansion. Z divided by z plus 1 whole square by power series expansion. To how to solve this? Again listen carefully. We shall take u bar of z as z divided by z plus 1 whole square. Okay? Units. Anybody?
Take z outside from.
Yeah, correct. From the denominator, let's take z outside from the denominator. You have over here z divided by, here you have z plus 1 whole square, correct? Z plus 1 whole square. From that, if you take z outside, it will be 1 divided by 1 plus z whole square, power square. From this only you take z outside. If you take z outside, 1 plus 1 by z remains. So now here you have z into 1 plus 1 by z whole square, which is nothing but z square into 1 plus 1 by z whole square. Okay, z square into 1 plus 1 by z whole square. Now one of the z get cancelled, so we will have 1 by z into 1 divided by 1 plus 1 by z whole square. Is it clear to everybody?
Yes, ma'am.
Yes, ma'am.
Okay. Now, next step what we do here is we shall take u bar of z as 1 divided by z into, here whatever is there no denominator, take it to the numerator. When you take it to the numerator, it will be 1 plus 1 by z power minus 2. Am I correct? It is there in the denominator, take it to the numerator. When you take it to the numerator, it will be power minus 2. Is it correct?
Yes.
Yes, ma'am.
Okay. Now you use this expansion 1 plus x power n. 1 plus x power n. This can be done using binomial expansion as well as Taylor series. No, this here you have to use a binomial expansion, but it is easy to remember. What you do here is, it is the expansion of this is 1 plus nx plus n into n minus 1 divided by 2 factorial into x square plus etc. It continues. Okay, this is one more expansion which you need to remember. 1 plus 1 x power n is 1 plus nx plus n into n minus 1 by 2 factorial into x square. Apply that to this term where what is n? What is n?
-2, ma'am.
What is x?
1 by z, ma'am.
Yes. Now apply this formula to this term and tell me what will be u bar of z. U bar of z is 1 divided by z into 1 plus x. X is 1 by z, n is minus 2. So according to the expansion, first term is 1 plus n into x. N is what? The power, which is minus 2 into x. X is what? 1 divided by z. Plus second term, n is what? Minus 2 minus 2 minus 1 divided by 2 factorial, which is 2 into x square. Correct? Yes or no?
Yes, ma'am.
Okay. Go for the next one. Go for the next one. What is the third term over here? It will be n into n minus 1 into divided by factorial x cube. So what it will be? Minus 2 into minus 2 minus 1 minus 2 minus 2 divided by 3 factorial is 6 into x is what? You have forgot to replace x. What is x? 1 by z. Here it will be 1 by z whole cube, etc. So what do we get over here? Just simplify and write 1 by z into 1 minus 2 by z. Here what happens? It is minus 3 minus 2. 2 get cancels. Minus 3 into minus 1, it is plus 3 divided by z square. Is it correct? Here minus 2 minus 1 is minus 3 and 2 get cancels. Minus 3 into minus 1 is plus 3. Correct? Yes?
Yes, ma'am.
Okay, now here you have minus 3, minus 4, correct? Then what we can do over here? It will be negative because 3 times negative sign is there. 2 ones are, 2 threes are, 3 get cancels. So what remains? 4 remains. So minus 4 divided by z cube. Is it okay, everyone?
Yes, ma'am.
Anybody, any doubt? Just put it in the formula. Value of n here it is minus 2 and x is by z. Substitute the value of n and x, we get this expansion. So this is what? U bar of z. Next step what we do is we multiply that 1 by z to the entire expression. So what do we get? 1 by z into 1, it is 1 by z. 1 by z into minus 2 by z is minus 2 by z square. 1 by z into 3 by z square, it will be 3 divided by z cube. Then 1 by z to minus 4 by z cube, it will be minus 4 by z power 4 plus etc. So this is our u bar of z. Write this in terms of the power series, that is summation. Summation, tell me what might suit over here. Here you have 1 by z, 2 by z square, 3 by z cube, 4 by z power 4. This is one of the easiest one. Alternatively plus negative, so it will be power of minus 1. Then check 1 by z, 2 by z square, 3 by z cube, 4 by z power 4. So how it can be of the form? Very easy it is. 1 by z,
Z
2
raised
by
to n
z,
plus 1, ma'am.
minus 1 power? No. See clearly it is 1 by
minus
z.
1.
Minus 1 power?
N plus 2 into 1 by z then, ma'am.
It is not clear. Minus 1 power n
Plus 2, ma'am.
and
1 by Z. Into
1
1
by
by Z.
z power n.
Yes, ma'am.
Will this give the same answer to you? Check for n equal to 0. Minus 1 power 2 divided by 1 power z square. So where will I write 1 by z? This will come 1 by z square. But I want first term as 1 by z. This doesn't work. I told you this is
n
the
into
easy.
z power n.
Huh?
N into 1 divided by z power n.
That is correct. Here you get. I said just a C. 1 by z, 2 by z square, 3 by z cube, 4 by z power 4. So it can be written as n by z power n. Am I correct? See here. When you put n equal to 1, it is 1 by z. N equal to 2, 2 by z square. N equal to 3, 3 by z cube. N equal to 4, 4 by z power 4. So it is the easiest one. But now you need to work on the term that plus minus. What will suit? Here it should be positive. Minus 1 power what will be positive? You should start with a 0. If you put what number, it will give you positive. What it will give you positive? What number will give you the positive in the first expression? Minus 1 power n will not give, because when n equal to 0, it will be anything power 0, that is correct. But if you put n equal to 1, minus 1 power 1, it will be minus 1. Is it okay? Can we write that? Minus 1 power n. Is it okay? Or shall we go for what happens if you put n equal to n, power as n minus 1? Now you give different values for n equal to 1 power 0 minus 1. It is minus 1 power minus 1. What is minus 1 power minus 1?
Minus 1, ma'am.
Okay. So is it okay? Can we put that? Can we put that? When n equal to 0, minus 1 power 0 minus 1. Minus 1 power minus 1, which is what? 1 by minus 1, which is minus 1 only. But we want positive over here. Even this doesn't work. Even this doesn't work.
n plus
Let's check whether n plus 1 works. Minus 1 power n plus 1. Put n equal to 0. Minus 1 power minus 1. Minus 1 power 0 plus 1, which is minus 1. Even n plus 1 doesn't work. Check for n. Check whether minus 1 power n works. Give different values for starting from n equal to 0. Anything power 0 is 1. Give n equal to 1. Minus 1 power 1 is minus 1. Give n equal to 2. Minus 1 power 2 is plus 1. So we are getting here 1 minus 1 1. So what will be the answer over here? N equal to minus 1 power n. Am I correct? Am I correct?
Yes, ma'am.
Okay. Is it okay, everyone? Is it okay? Now give different values for n starting from n equal to 0. Minus 1 power 0, 0 divided by, so n will be 0. No, here it also doesn't work. Z power 0. Here we will get 0. Even n doesn't, n is not correct.
no, ma'am.
N also not correct. Check for n minus 1. Check for n minus 1 now. When n equal to 0, minus 1 power 0 minus 1. So 0 divided by, I think it is not possible for 0. So you need to change it for n equal to 1. Now you check. Now you start from n equal to 1. So for 0, this term does not exist. So start with n equal to 1. What happens when you put n equal to 1? Minus 1 power 1 minus 1, 1 by z. So minus 1 power 0 is 1, so you get 1 by z, which is correct. Now give n equal to 2. Minus 1 power 2 minus 1 into 2 by z square. Minus 1 power 2 minus 1 is 1. Minus 1 power 1 is minus 1 into 2 by z square. So minus 2 by z square. So only the thing was you should start it with from n equal to 1, not from 0. Equal to C. I hope you all have understood what is the problem we are facing over here. Even if it is n equal to 0, so when you have n term over here, you cannot put n equal to 0. The entire term will be 0. So it should start with n equal to 1. If n equal to 1 you put, you will get back the same expression. So this is the nth term of the series. U bar of z equal to summation n equal to 1 to infinity minus 1 power n minus 1 n into z power minus n, which you can compare with summation n equal to 1 to infinity un z power minus n. So when you compare here, what is un? This is the un term. Z power minus n is the common term. So we know that z transform of un is u bar of z, implies inverse z transform of u bar of z is what? Un. That's why the inverse z transform of the given function is nothing but un, and this is our un. What is un? Minus 1 power n minus 1 into n. Is it okay, everybody? The problem or the difficulty you might face in writing the nth term of the series. That's it. Rest everywhere it is okay, I suppose. What do you all feel? Anybody? Yeah. Okay. So just working out is the only solution. So you can overcome that difficulty. So let me solve the last question. That is, you need to find the inverse z transform of e power 1 by z, and we have to prove that it is equal to 1 by n factorial, and inverse z transform of z into e power 1 by z minus 1, and which we have to prove it to be 1 by n plus 1 factorial. Proving these is the questions is very easy, isn't it? Because the answer will be given. Proving the things are easy because we know the answers, but we need to prove that. How we get it, we need to prove that. So what expansion we will be using here is, first I'll take, let u bar of z is equal to this one, e power 1 by z. What here is of e power x expansion, 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial. So this is the expansion of e power x. Now here we have e power 1 by z. So u bar of z is e power 1 by z, that is equal to what? X you have to replace by 1 by z. So when you replace x by 1 by z in this expansion, we get 1 plus, what do we get? X is 1 by z, so it will be 1 by 1 factorial into 1 by z plus this x square. 1 by 2 factorial into x is 1 by z, so it will be 1 by z square plus 1 by 3 factorial into x cube. X is what? 1 by z, so it will be 1 by z cube plus etc. Is it okay, everyone? Substituting x by 1 by z, that's what we have done. Is it okay?
Yes, ma'am.
Okay. Now write the nth term of this. Very easy it is. Tell me, what is the nth term of this? N equal to 0 to infinity. What is the nth term of this? You know the answer over here. So how can we write this entire expression as? Tell me.
1 by n factorial into 1 by z power n.
Yeah, very good. It is 1 by n factorial into 1 by z power n. Very easy it is. Give different values for starting from n equal to 0. We see, remember 0 factorial is 1. Okay, for your information 0 factorial is 1. So you get when n equal to 0, it is 1 by 0 factorial into 1 by z power 1. Z power 0, n equal to 0. So this will be 1. So we get the first term of the series. When n equal to 0, 1 by 0 factorial into 1 by z power 0. Anything power 0 is 1, 0 factorial is 1, so we get 1. Now give n equal to 1. It will be 1 by 1 factorial into 1 by z power 1, which is 1 by 1 factorial into 1 by z. Give n equal to 2. 1 by 2 factorial into 1 by z square, which is the third term. So this one suits. So this can be written as summation n equal to 0 to infinity 1 by n factorial into z power minus n. 1 by z power n can be written as z power minus n. Compare this with a formula. Definition of Z transform. Z transform of un is summation n equal to 0 to infinity un z power minus n. So Z transform of un is some u bar of z, then inverse Z transform of u bar of z is what? Un. So this is our un now. That's why inverse Z transform of u bar of z is un, where un is 1 by n factorial. Is it okay, everyone?
Yes, ma'am.
Okay. Go for the second part. What we have to prove? This one. The inverse Z transform of z into e power 1 by z minus 1 is 1 plus 1 divided by n plus 1 factorial. That is what we have to prove. So similar case over here. We need to find the inverse Z transform of z into e power 1 by z minus 1. This is what we have to prove. So we have the expansion of e power x, which is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial, etc. So what is the expansion of e power 1 by z? 1 factorial into z plus 1 by 2 factorial into 1 by z square. Just replace x by 1 by z. 1 by 3 factorial into 1 by z cube plus 1 by 4 factorial into 1 by z power 4, etc. So just replace x by 1 by z in this expansion. Now we have to find z into e power 1 by z minus 1. This is e power 1 by z. So what will be e power 1 by z minus 1? Subtract minus 1 from both the sides. So this 1 get cancels if you subtract. You get 1 by 1 factorial into 1 by z plus 1 by 2 factorial into z square plus 1 by 3 factorial into 1 by z cube, etc. Subtract minus 1 from both sides. So when you subtract minus 1 plus 1 will be 0. Now multiply by z. Z into e power 1 by z minus 1. So when you multiply by the entire expression, this entire expression by z, what happens? This entire expression you multiply by z. First term, z get cancels, 1 by 1 factorial remains, plus 1 by 2 factorial into z square and z. 1 z get cancels, 1 by z remains, plus 1 by 3 factorial into 1 z get cancels, 1 by z square remains. Is it correct? When you multiply by z to the entire expression, this z and this z get cancels. Second z remains. Third expression z square remains. Am I correct? Yes or no?
Yes, ma'am.
Okay. So I hope this is clear. Now write the nth term, summation n equal to 0 to infinity. See, 1 by 1 factorial, you do not have a z term. 1 by 2 factorial, their power of z is 1 less than this term. See here also, z square, power of z is 1 less than this one. So it will be of the form 1 divided by n plus 1 factorial into 1 by z power n. Check now, give different values for n and check whether it satisfies n 1 plus 1 factorial into 1 by z power n. Start with n equal to 0. 1 divided by 0 plus 1 factorial into 1 by z power 0. Z power 0 is 1, 1 factorial is 1. So you get 1 by 1 factorial, first one. Give n equal to 1. If you put n equal to 1, it is 1 by 1 plus 1 factorial into z power 1. 1 by 1 plus 1 factorial is 1 by 2 factorial into 1 by z, which is the second term. Now you give n equal to 2. What happens? It will be 2 plus 1 factorial into z power 2. 2 plus 1 is 1 by 3 factorial into z square. 1 factorial into z square. It is the third term of the expression. So I hope this is clear, the nth term. So similarly, this is what? This is our u bar of z and this is our un. This is our un. That's why inverse z transform of u bar of z is un, which is 1 divided by n plus 1 factorial. Is it okay, everybody? Is it okay?
Yes. Yes, ma'am.
Okay, if you have any doubt, please work out these questions. Those who are finding it difficult, I expect you all to go through the previous method only. Study only by the method of partial fractions. Those who are finding it difficult. If you are finding difficulty, I can tell you all what you all need to study. So study only the things which I tell you all. Those who are finding it really difficult, because studying everything and not able to understand anything is also not correct. Those who are finding it difficult, because online process is little difficult to study maths, I can understand that. Studying maths online is difficult, I can understand that. That's why those who are able to follow it, you work out. But those who are not able to follow the things, you contact me. I'll tell you all what you need to study. So study only those things. It will be easier for you all as well. Instead of studying everything and will not be remembering anything or not understanding anything is not correct. But whatever you study, study perfectly. You should be perfect in whatever you study. That's it. Whether you study 2 modules or whether you study 3 modules, whether you study all the 5 modules. Some of you are capable of studying all those things. Those do it. Those do it with perfection. But those who are, example, and those who are like having a previous year, so for those people, whatever you study the things perfectly, so that whatever is asked you are able to do it. You study the minimum things, but you should be perfect in those minimum things. Then you will be able to clear mathematics. It is not a problem. Okay, so I expect you all to study whatever I discuss in class. Study that much. If you are not able to understand, contact me. If it is important, I will tell you all to study and I'll explain you all. If it is not, so you can go for some other topic. It is not that everything is difficult. There are some concepts easy. So those who are finding it power series method difficult, study only the method of partial fractions method. Okay, so if you have any doubt, you can contact me. So right now you can go through whatever we are studying, because next week is the internal. We will begin with that half range, isn't it? Last time for the second internal we have stopped with half range Fourier series. We have not included half range Fourier series. So this time for the second internal you can start studying from half series, and we can stop till here, power series method. Starting from half range, we will have the questions up till power series. Difference equation is the last topic which is pending, okay, which we can include it later on. Okay, let's meet in next class. That's tomorrow morning, first hour. See you all tomorrow.